Now we're going to look at a series of videos here where we see the effect of transforming a graph, what effect that has on the derivative of the transformed graph. So if we know how the original graphs are related by some basic transformation, the question is, how are the derivatives related? We're going to look at this, of course, as we usually do, algebraically and geometrically as well. So let's start with some transformations. Let's start with some translations. So that a horizontal shift, remember, is going to turn out to be a horizontal shift of the derivative. So we can see this. Now remember, to do a horizontal shift, as we've just seen in our previous videos, we replace x by x plus h. Now the derivative of f of x plus h by the chain rule is the derivative of f at x plus h times the derivative of x plus h, but the derivative of x plus h is 1. So the derivative of f of x plus h is the derivative of f evaluated at x plus h. So if you think about that, what we've done is not only have we replaced x by x plus h in the original function, we've replaced x by x plus h in the derivative. So what that says is, if you shift horizontally by some number, you're going to shift, if you shift the function by that amount, you're going to shift the derivative by exactly the same amount. So the tangent lines, for example, would be parallel from pre-image to image point, and shifted from horizontally. So let's look at an example. Let's just start with something easy like y equals x squared. And first of all, what's the formula for translation 5 units to the right, and then how do the derivatives compare? See if you can work this out. Well, we're going to go 5 units to the right. We replace x by x minus 5. So it would be g of x is the translated version, which is x minus 5 squared. And so the blue is the original, and the green one is g of x, 5 units to the right. Now g prime of x is 2 times x minus 5, which is the same as f prime of x, which is 2x, with the x replaced by x minus 5. So its derivative is just shifted 5 to the right. So the derivative of the blue one is the red one, 2x, and the derivative of the green one is the purple graph, 2 times parentheses x minus 5. So we see that the purple graph is just shifted 5 to the right from the red graph. So if you shift horizontally, you just shift the derivative horizontally by the same amount. On the other hand, a vertical shift ends up not affecting the derivative at all. This is a very important result here, particularly for us in calculus. So if I take if I shift by k vertically, I'm replacing, starting with the function y equals f of x, replace y by y minus k. I can solve by adding k to both sides to solve for y. Now when I take the derivative of that y with respect to x, I'm taking the derivative of the right side, and the sum rule says that's the derivative of f, which is f prime, plus the derivative of k, which is 0, because it's a constant. And so we see that they get the same thing. So for example, if we take f of x equals x cubed and g of x equals x cubed plus 4, notice that's like y equals x cubed and then y minus 4 equals x cubed. So the g of x is just 4 shifted, it's the f of x shifted straight up 4 units. Okay, so the original is the blue, and the image is the red here in this case. So the blue is the f of x, the red is the g of x. But when we do the derivatives, either way, we're going to get 3x squared, with the same derivative in both cases. Another way to think of this graphically is we take a point and its derivative and shift them up. The two tangent lines are going to be parallel, and they're going to have the same slope, so they have the same derivative. Okay, in the next video we'll look at what happens with strains.